Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this video we are going to see one more problem which is based on area between two curves. Let us start with problem number 8. Two points A 1,4 and B 9,12 are on the parabola y square is equal to 16x. Show that the area enclosed between the chord AB and the parabola is 16 upon 3. They have already given that A and B lies on the given parabola. So let us start directly by drawing this curve. Parabola is y square is equal to 16x. The power of x is less and it is positive. So I will draw a parabola in positive x-axis direction. Now the points A and B lie on this parabola. So out of that A is 1,4. Assuming that here we have A 1,4 and the second point is B 9,12 which is again in the first quadrant. Let us connect this AB in order to draw the chord. So they have asked you to find the area which is enclosed between the parabola and the line, or you can say chord AB. So this is the area. Now here also to find this area, we can consider the area of parabola from point A to point B with respect to x-axis, so that this will be the entire area, and further we can subtract the remaining area which is formed by the line AB again with respect to x-axis. Since we are calculating the area with respect to x-axis, the limits of x will be 1 to 9 and the formula will be integral y dx. So area can be written as integral y dx minus integral y dx. The first y will represent the y from parabola and the second y will represent y from the line. But here you can see the chord AB, we don't have its equation. Therefore the next step is to find the equation of chord AB. So let us consider this as equation number 1. But before that, the limits of both the integral will be from 1 to 9. For chord AB, we have 2 points A and B, and if we want to find the equation of AB, we can use the 2-point form. For that we can take A as x1 y1 and B as x2 y2. So let A is equal to x1 y1, that is 1,4, and B is x2 y2, that is 9,12. Further we have 2-point form as y minus y1 upon y1 minus y2 is equal to x minus x1 upon x1 minus x2. Let us substitute the values of x1 y1 and x2 y2 in this equation. This will give you y minus 4 upon 4 minus 12 is equal to x minus 1 upon 1 minus 9. We have y minus 4 upon minus 8 is equal to x minus 1 upon minus 8. Minus 8 will be cancelled. Y will be x minus 1 plus 4. That will be x plus 3. So let us substitute the value of y in equation number 1. That will give you A is equal to, the first integral stands for the parabola, and the value of parabola in which y will be equal to under root 16x minus integral 1 to 9. The second y dx will represent the line which is x plus 3 dx. Square root of 16 will give you 4. Square root of x can be written as x raised to half dx. The remaining part remains the same. Integration of x raised to half will be x raised to 3 by 2 into 2 by 3. Integration of x is x square by 2 plus 3 integration of dx is x. This will give you 4 into 2 8 upon 3, and after substituting upper limits and lower limits we have 9 raised to 3 by 2 minus 1 raised to 3 by 2 minus 9 square by 2 plus 3 into 9 minus 1 square by 2 plus 3 into 1. Further, 9 raised to 3 by 2. So you can take square root of 9 first, that is 3, and 3 cube will give you 27. Minus 1 followed by 9 square is 81 by 2 plus 27 minus 1 by 2 plus 9. So the remaining part will be 8 by 3 into 26 minus 81 by 2 plus 27 minus 1 by 2, and minus into plus will give you minus 3. In the next step, 81 by 2 minus 1 by 2 will give you 80 by 2, and 27 minus 3 will give you 24. 80 upon 2 will be 40, and 40 plus 24 will give you 64. 8 into 26 will give you 208 upon 3 minus 64. We have 208 minus 64 into 3 will give you 192 upon 3. 208 minus 192 will give you 16 upon 3. Thus the question was asked to prove that the area is 16 upon 3 square units. So this part is proved. I hope friends you have understood this problem. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.